And good afternoon everyone. Okay, so for this video I would like to do a recap for the topic for complex number. Okay, so for complex number, right, it is actually includes a real part and also imaginary part, and then the form for complex number is in the form of z equal to x plus yi. By right, x here is the real part, or usually we real part of z. Usually we represent it with re z, real part of z, and then y here is the imaginary part of the z, which is the complex number, and we represent using iz, which is imaginary. Okay, and then we can write this the complex number that we have here, this one, z is equal to x plus yi. It is actually a Cartesian form. Okay, which is z equal to x plus yi, and then here if you see we have I, so this I is actually square root -1. We define it this way in order for us to solve equation that has no real solution. Okay, I give you example. Yeah, let's say if we have x squared plus 1 equal to 0. Here we move 1 to the right side, you're going to get -1 bar. And then here we cannot do anything because right now if we want to find the value of x, by right we have to square root both sides, right? Okay, when we square root both sides, okay, we have to put plus minus here and then here -1. So that's why here we cannot solve, because square root negative, there is no solution. Just like how we have b squared minus 4ac, in order for us to find the number of solution for that particular quadratic function. Okay, we use b squared minus 4ac, right? When you substitute b, a and c here, you're going to get less than 0, which mean you will get which mean there is no real solution in the quadratic function. So the same concept here. So what happened is that the mathematician says that let's create a number where the square is actually -1. Okay, so that's why they introduce the complex number, which is we have I squared equal to -1. Okay, and then by right here, in order for us to find I, it is square root -1. So that is how we get to introduce with the complex number. And then here, let's say if I have square root -2. So by right, square root -2, we can separate them with 2 multiplied with -1. And then we can use the rule of index, where we can separate them 2 multiplied with square root -1. Then 2 here, you just maintain as 2 multiply with this guy is I, so that's why it becomes square root 2i. So that is how we use complex number lah. Okay, and all of the complex number, it actually has conjugate. Okay, it has conjugate, which is, let's say if we have z is equal to x plus yi, by right the conjugate is conjugate z, which we represent using the z symbol as well, but then we have bar on top of it. Okay, it is x minus yi. Okay, here if you see the real part, which is our x, stay the same. Yeah, this one stay the same, but then for imaginary part, change sign from positive to negative. Or let's say if you have from you have negative value, then you change it to positive lah. I give you an example. Yeah, let's say if I have w is equal to 5 plus 2i, then when you want to find the conjugate of w, you copy w, put hat on top of it, a bar, sorry, and then real part stay the same, which is 5. Then 2 here, you change the sign, which is -2i. So let's say if I have another one, which is maybe m, I just put on m is equal to 4 minus 7i. When you want to find the conjugate of m, okay, you put bar on top of it, 4 plus with 7i. So that is how you find conjugate lah. Okay. And now, for complex number, just like how we have, let's say we have a normal equation x plus y or equal to something something, right? We actually have Cartesian plane, okay, x and y exist, okay. Also the same for complex number, we also have diagram, okay, where we call it as Argand diagram or complex plane. Just like how we have Cartesian plane, this one we call it as complex plane. So by right, it is similar with x and y axis. Okay, at x-axis it is our real part, which is x just now. Okay, and then at y-axis we have our imaginary part. Okay, so if you have the value of x and y inside the complex number, then you can just draw here. Let's say I give you for w here, which is 5 plus 2i. So by right, our x here or our RE is equal to 5, our y or our imaginary is equal to 2. So this is 5, 2 ba? So maybe this is 5, this is 2. So by right, your vector is at, sorry, your complex number, it is at this. Okay. Okay, now we proceed to the next one. For complex number, we have the Cartesian form, right? We also have another form where we call it as a polar form. Okay, we call it as polar form. Okay, for polar form, when let's say our Cartesian form is Cartesian, is z equal to x plus yi. For polar form, when you want to convert it, it should be z equal to r multiply with cos theta plus with I sin theta. By right, this guy cos theta plus I sin theta is actually cis theta. So you can convert this to r cis theta. Okay, where when you see r and also r and also theta here, you don't know what value you have to put, right? So by right, r is actually the modulus of z, which is, you can just find square root plus x square plus y square, and then theta, which is our argument z, it is actually inverse tangent y divided by x. Okay, and then here we have the principal argument of z, which is that argument z is should be starting from negative 180 until 180, or you can change it into radian, which is you're gonna get negative pi to 2 pi. Okay, so by right, if you have Argand diagram, right, or complex plane, okay, so by right, when you want to put the angle, it should be starting from the x-axis, which is starting from here, or if you want to use below also can. This one, when you want to use starting from x-axis to anti-clockwise, okay, anti-clockwise like this, you can put the angle as positive. When you want to use the below one, which is below horizontal axis, if you see the angle is actually moving clockwise, right? So here you have to put the value of angle, the angle as negative value. Okay, so let's say I give you an example. let's say when you find the angle, okay, the theta you got, maybe you got here, and then let's say the theta is equal to 35, so you still can put theta is equal to 35 lah. Let's say you have your angle is equal to as is at this side, which is starting from here until here, you get equal to 138 degree. So you can put theta equal to 138 degree. But then let's say if you get below, let's say this is your angle. Oh, sorry. Okay, this is your angle starting from x-axis until the line that you have here. The angle is equal to, let's say, equal to 58 I put. So if you get 58, by right, inside theta you have to put negative 58. Why? Because it is below horizontal axis, below x-axis. So let's say if your graph, your complex number is starting from at this line, so by right you will start to find the angle starting from the x-axis clockwise until the line. Let's say you got here equal to 150 degree. So by right you have to put negative 150 degree. Okay, so that is how you can do for to put the angle for, that is the principal argument of Z lah. Okay, so other than the polar form, you also have another form, we call it as exponential form. Okay, exponential form also similar, but then here you can also similar, which is Z. Here it is Z equal to R e to the power of I theta. So by right, R is also the same or the similar formula, which is modulus Z square root of x square plus y square. Okay, let me write it properly. X square plus y square. Theta is inverse tangent y divided by x, and principal argument also the same. Argument Z just now is starting from negative 180 until 180, or in radian it is negative pi until pi. Okay. Okay, now we will go through exercise in the tutorial question. Express complex numbers in the exponential form. Okay, so we have question B, which is Z is equal to 2 minus 3i. So first we have to remember that exponential form is Z is equal to RE to the power of I theta. Okay, now we proceed to answer the question. So when we want to write in this form, exponential form, you have to find R first, and then you have to find theta. So you have to find R. R is equal to square root x square plus y square, where here your x is equal to 2. Okay, this is your x, negative 3 is your y. 2 square plus with negative 3 square. Here you're gonna get total equal to square root 13. Okay, and then we can find our theta, which is inverse tangent divided with y over x. Okay, so inverse tangent, y is equal to negative 3 divide with x is equal to 2. The answer you will get is equal to negative 56.31. The reason why you get negative here is, let's say if we draw in the complex plane our x and y. Okay, what your x is 2, let's say here is 2, and then y is negative 3. Let's say this is negative 3, and your point is here, right? So you're gonna have a line from origin to this point. Okay, so by right, the angle that you get, which is 56.31, is here. And since this is below horizontal axis, so below horizontal axis, so that's why you get negative lah. Okay, so we have to put theta is equal to negative 56.31. Okay, now You already got r, you already got theta. Now you can just substitute inside the formula, which is z is equal to r exponent I to the power of I theta. So your r is equal to square root 13 e to the power of negative 56.31 degree I. If you want to put your answer in degree, okay, if you want to put answer in exponent, in radian also can, which is square root 13 e to the power of, you change 56.31 to radian, which is you're gonna get negative 0.982 I. So that is how you do for question B. Okay, now proceed to question D, where we have z is equal to 2 cos 2 pi over 3 minus with I sine 2 pi over 3. So if you see here, right, it's not like the previous question where we are given in the form of, the question is in the form of Cartesian. So this one they provide to us in the polar form. So what you have to do is here, okay, first we will change this, we will extract r and theta from the polar form. So but then we have to change in a proper way by right here. It seems like this is actually a polar form, but then the polar form is z equal to r cos theta plus with I sine theta. According to our question here, it is minus, or it is minus here. So how to do this one? First of all, you have to know that if we have cos, it is actually equal to cos theta, it is actually equal to cos negative theta as well. If you have sine theta, it is also similar with negative sine theta. Okay, so now from our question, okay, what we will do is we will change this guy. Okay, so we will change to 2 cos negative 2 pi over 3. You still gonna get cos 2 pi over 3 plus with, okay, I sine negative 2 pi over 3, which is also the same as negative I sine 2 pi over 3. Okay, so from here I will change into the formula, change to the polar form r cis theta. So I have 2 cis theta, which is equal to 2 pi over 3. So from here I get value of r, which is equal to 2, then theta, which is equal to negative 2 pi over 3. So what I can do after that, just substitute inside r e to the power of I theta. So my r right now is 2 e to the power of I theta. Theta is 2 pi, negative 2 pi over 3 I. So this is the answer in the exponential form. Okay, the next question we have e is equal to question e, which is z is equal to negative 3. So by right, z is equal to negative 3 is plus with 0 I, because we don't have the imaginary part here. So that's why we can just assume that imaginary part is 0 right now. Okay, and the next step is from here we can get our r, because this is our x and 0 is our y. So from here we can get our r, which is square root negative 3 square plus with 0 square, you're gonna get equal to square root 9, which is the answer. You will get 3. This is your r. Now you find theta, which is inverse tangent equal to y over x, which is the answer. You will get is inverse tangent 0 over negative 3. Okay, by right, if you draw this in the Argand diagram, okay, so by right, your x is equal to negative 3, okay, and then y is equal to 0. So your point is here. So your line is basically here. The angle that you want to know is starting from x-axis horizontal positive x-axis until the second quadrant here. So which is, if you see, right, the angle is equal to 180 degree, or you can put it as pi also can. Okay, so here you can put it as pi as well. Both are accepted lah. So already you have your r, you already have your theta. So your complex number in exponential form is re to the power of I theta, which is equal to, right now r is equal to 3, e multiply with e to the power of pi I. That's it for question E. Okay, now we will proceed to the second question, where they ask us to express 2e to the power of 1 plus pi over 2i in the form of a plus bi. By right, they want us to write this into the form of Cartesian, no? Okay, so from here we have z, which is in the exponential form. Z is equal to 2e to the power of 1 plus pi over 2i. And then here you can separate e2, e1, e to the power of 1, multiply with e to the power of pi over 2i. And then you will get 2e multiply with 2e. E to the power of 1 is 2e lah, is e lah. Okay, and you have pi over 2i. Now from here you can see that this guy is your r, pi over 2 is your theta. Okay, now from this you can change it into the polar form, which is you can have z is equal to r cis theta. So your r is equal to 2e, cis theta is pi over 2. Now z you can change to x plus yi. Okay, and then here 2e you maintain, cis pi over 2 we change into the trigonometry form, which is cos pi over 2 plus with I sin pi over 2. And then you expand them. Okay, this one you maintain, you will get 2e cos pi over 2 plus with 2e sin pi over 2i. Then from here you can compare the component of x and y. So for component x it is 2e cos pi over 2. For component y it is 2e sin pi over 2. So from here it is x is equal to 2e cos pi over 2, where you're gonna get the answer is equal to 0. And then for y you're gonna get 2e sin pi over 2. The answer you will get here is equal to 2e. So by right, your x and y already here, then you can substitute into the Cartesian form, which is z is equal to x plus yi. Then you will get z is equal to 0 plus 2ei, and then z is equal to 2ei. So this is your final answer for this question. Okay, I will continue to the next part. Thank you.